modeling. Okay, yes.
Yeah, can you repeat the anomaly?
Professor, what's the guideline?
Guideline?
Guideline of what? These are the 3 anomalies.
Yeah, anomaly. No such an anomaly. If you cannot find such an anomaly from your modeling, it will be good enough. However, if your modeling caused this kind of anomaly, then you need to do something. That is a segmenting. Okay? So second guideline is, can you find any anomaly? Then that is not good enough. So you need to segment. But if there is no anomaly, no unusual thing, if everything is perfectly fine, then that means your modeling is good quality enough. Okay? So that is the second. First guideline is one relation, one meaning. Actually, first one and second one is related. It's almost the same meaning. Since there are 2 different meanings in one relation, that cause problem of insert anomaly, delete anomaly, updating anomaly. Okay? So that is the. So these are the example of the bad example. So employee underbar department. So let's say this is your initial result of your model. Since it has 2 meanings, it doesn't obey the first guideline. Even it caused many anomaly problem. This is the same thing. How many meanings? 1 for employee. Another one is for project. Third one is for the workshop. Okay. So this is the, what is it called? Schema plus data. This is called database state. Okay, this is a database state for your initial modeling, employee department, employee project. You can see a lot of redundant information. You can see a lot of redundant information. You can see a lot of redundant information. As I said, database really hate this kind of redundant information that causes the problem of anomaly. So when I delete the project X, it will delete this one, this one, this one, and this one. So 2 employees will be deleted automatically. That is delete anomaly. Okay. So second guideline is no such an anomaly. The third guideline is, if you have such a one huge relation, not all the attribute has the value. Sometimes not. At that time, what can you use? You can use null to indicate this value does not have any value. This attribute does not have any value. So you may have many null in this model. Null does not make any chaos or to crash your system. It's even not anomaly, but if you have many nulls in your database model, which means actually you don't need such a value. So it will be waste of space. Also very hard to manage the integrity. So you'd better have less number of what? Null in your modeling as possible. So as less null as possible. That is the third guideline. However, we cannot make the null-free database model. We cannot avoid entirely null. No. So it's inevitable to have the null values in your modeling, but as less as possible. That is the third guideline. The next one is a little bit hard to understand. So to do that, I will explain one more time this. So when we access, so one of the transaction, one of the application that you need to implement from this database is I'd like to retrieve employee name and department name. So how can we access the data? We can find the department number. Then using department number and foreign key, you can identify the specific data in reference table. To do that, we can use the join operation. Actually, if we learn the SQL, structured query language, as well as the relational algebra that we are going to learn next week, so you probably understand very easily such an operation join. However, I intentionally put this chapter in before the relational algebra because this is the last step of your modeling. From relational algebra is close to the application. Okay. However, this is the operation. So if you do not understand clearly what is the join operation, we will learn the next class next week. Then why don't you go back to this one? So anyway, this is called the join operation. If your modeling is not good enough, sometimes join operation produce the unexpected data. It's called the spurious data. Spurious tuple. What? Actually, join operation try to find the matched data. Matched means using this the foreign key column. What is number 5? So number 5 is here. So John Smith 1, 2, 3, 4, 5, 6, whatever 5. Then we search it and the manager social security number will be added, appended next to each tuple. What about the 1? Frankly, it has 5, so this tuple will be attached, and number 4 will be attached. 4 attached, 5 attached. So this is the join operation. Combine two relations into one big one. That is the join operation. However, if your modeling is not good enough, that may cause the problem. For example, this. We have two relations. Employee underbar location, E name, P location. And another one is a social security number, P number, hours, P name, P location. We are going to use this P location. That is called the natural join. Natural join means even though this is not a foreign key, in relational algebra it allows to join non-foreign key column too, as long as they are matched. Especially if the names are the same, we can automatically combine. That is called the natural join. We will learn the details later. So, which means we can combine two relations using P location. For example, Belair is Smith, John Smith. Sutherland, John Smith. So, Belair, we can add John Smith. And Sutherland is John Smith. And Houston is Ramesh. Ramesh will be added. And Belair is John Smith, will be added like that. Actually, social security number 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Who is 1 to 9? Actually, John Smith is the 1 to 9. However, Sutherland is over here. Also, Joyce English is the Sutherland. So, will be copied and added one more time. As long as the value is matched, it will combine. So output will be like this. The first row, that's what actually we expect such a data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2.5 hours, product X, and Belair, John Smith. However, since Joyce English works for Belair too, so it will be matched, then joined. Okay? Then this one will be merged. So that means 1 through 9, Joyce English. Actually, that is not real data. Okay? Why? The S-service start tuple are called spurious tuple. Okay? Unexpected tuple. Why this spurious tuple will be written? Because your modeling is not good. It's very hard. So employee name and P location. Employee location, employee. Project location also, it has social security number, P number, hours, P name, P location. is complicated. Okay, it's not well organized, or it has many different meanings, like the project location and project number and number of hours and so on. So you need to separate, reorganize such a thing. That is the fourth guideline. If the joint operation produces the unexpected data, that means your model has something wrong. So you need to correct that. Okay? Those are the general, the informal way of the informal guideline to make your initial version of the modeling better and better. Okay? It's easy to understand, but sometimes in real life project, this guideline is not enough. So you'd better have the perfect solution to make the model better and better. That is called the normalization process. So normalization will start with functional dependency. Let's see. Delete Kumang. What is a function? What is a function? Function. Do you know function? Yes. When did you learn? Probably upper elementary school, right? The 5th grade or the 1st grade. If you are smart, or the advanced, so 3rd grade. Set of entries. Can you give us the example of that function? Any functions? One-to-one. I think yes, one-to-one can be kind of function, type of function. Usually one-to-one. Function is one-to-one, right? What about the sine, cosine, tangent? Are they functions? Yes, it's a function.
Square root.
Square root. There are many functions, right? So what is a function? Yes.
A function, programming, it's a block of statements that can perform one task and return a value.
So there is an input, then there is an output. Okay, then output will be determined by the input data. Input will be processed inside the function. So when I learned the first time for function, my math teacher used this one. You don't know what happens, so this is called a black box. But when I put the number 1, what is the output? 2. When I put the number 2, is it 4? 3? What will it be? 8. So, how it works is double. It's 2 times, right? So we can guess 2 times. What about x? What will be the output? 2x. 2x. So, function f is x to 2x. Can you remember that? This is a function. Okay, sometimes you can use you are saying x to 1. Actually, each side should be a set. So that is the reason sometimes it's a one-to-one function or one-to-many function. It's possible, right? The sine, cosine, or sometimes this way, one-to-many, many-to-one, many-to-many are possible. That is a function. So y is equal to 2x or y equal fx. The meaning of function is this output value is determined by 1. Inversive. Can you remember? So inversive. Not always is inverted. Right? Which means like this one. But anyway, input decide the output. 1 to 2, 2 to 4. So we are going to use such a functional mechanism in our normalization process. For example, we have employed. So it has social security number as the key and name and address. Okay? Does it make sense? Social security number, using the social security number, I can find specific name. Does it make sense? Social security number determine name. Right? If you know, in other words, if you know the social security number, you can identify the name. So that is one. What about the social security number? Can determine address. What about social security number? Determine social security number. If you know the social security number, that is the social security number. So social security number also determine name plus address or SSN. Right? This one determine this. If you know something, you can define the tuple, data, attribute. This is called functional dependency. This looks like a function. Then, using this function, we can find whether the value is depend on specific value. In other words, a set of, this is a set of attributes. This is a set of attributes. Y. So if X determine Y, set of attribute determines set of attribute Y, we can say this is the functional dependency, FD. So can you, this is a functional dependency. This is another functional dependency. This is another functional dependency. So if you are very fast to understand this kind of thing, probably you recognize. What about the left-hand side? Left-hand side should be what? Key attribute. For example, name. Can name determine the other value? No. Sometimes duplicate data. So left-hand side should be unique data. So this one determine this. In this case, how many functional dependencies can you find? How many? Four? Four. More than four? What exactly four? More than four. Can you give us another example?
SSN name and address.
SSN. SSN.
Address
and then
Determine address
and name.
plus name. What else? Yes. This is true. It's a functional dependency.
SSN address.
Yes.
SSN
address.
SSN
and address.
and address. We are ready to do.
No, SSN and address.
Plus address.
SSN plus
No. SSN arrow
Plus
SSN and address.
address. Any other? We can make as many functional dependencies as possible. What about this? Social security number plus a name. Determine address. Does it make sense?
Yes.
Yes, because it's a unique. No matter how many attributes you add to left-hand side, you can identify the data. So, which means social security number, address, determine name. Social security number, address plus name, determine social security number. You can make as many combinations as possible. However, the left-hand side should have what? Key attribute. So if you can find such a key attribute, including key, this functional dependency is called minimal functional dependency. It's a minimum. So in other words, it's a poor. This is the most important functional dependency to decide the dependency in this relation. This is called minimal functional dependency. A set of dependency determines the other functional dependency. Anyone can explain why Professor Lee is mentioning about minimal functional dependency or functional dependency while we are discussing about the normalization or unit measure, quality of the relation. Yes?
This will describe briefly in mathematical way the function of that entity or that relation.
If you replace one word, it will be perfect answer. This functional dependency describe what? The meaning of this relation. For example, here, this is the meaning. Social security number determines this one. How many meanings? How many semantics in this? So one meaning. Okay, if you can identify, if you can find minimal functional dependencies. So in the informal way, according to the informal way, I just mentioned each relation has one meaning. Actually, it doesn't make sense in terms of mathematics. One meaning, what does that mean? So to make the formal way, mathematical way, we adapt idea of function, especially functional dependency. So if we can find such a minimal functional dependency, that means it has one meaning. It's a perfect solution, perfect modeling. So in other words, here, how many informal way, how many meaning does employee underbar dependent relation have? Two meaning. One is employee, left-hand side. Another one is right-hand side, department, two meaning. So it doesn't obey the first guideline. So formal way. So first you need to find functional dependencies, especially minimal functional dependency. That means social security number determine what? E-name, birthday, address, T number, E-name? No. Only up to T number. If you know social security number, you can find up to T number. That is one minimal functional dependency. You cannot divide, you cannot separate that minimal functional dependency. What about another one? T number determine T name and manager social security number. This is another functional dependency. So you have two functional dependency, which is not allowed in good quality of the relation and model. Okay? So in case you find two functional dependency, what you guys need to do? Separate. The only solution is to separate in database model. So that is the reason we need to find the minimal functional dependency. In this case, how many minimal functional dependencies? Employee social security number determine E-name. That's one. And project number determine project name and project location. That is another functional dependency. So that is the reason is indicated FT3. The last one is social security number plus P number left hand side determine hours. That is the third functional dependency. So from here we can have three different relations. That is normalization process. So we will learn such a normalization process in the next class. Actually, this one can be done by mathematical way. Actually, I skip how to find minimal functional dependency. This method I decide not to use such a mathematical way of minimal set of functional dependency. Sometimes, usually 90% of students cannot understand this one within such a short time. So sometimes, if I skip this one, the student can understand easily what is the functional dependence, what is the minimal functional dependency. But if I explain this one, forget about everything. Right? So I'm going to skip. But if you are interested in this algorithm, So you can study by yourself and ask me if you have any question regarding to the algorithm, how to find the minimum functional dependence. In real life system, actually you don't need this one. Very, very rare case you can apply this approach. Or if you want to build the algorithm computer program to normalize automatically, at that time you can use this algorithm to make automatic system for normalization. Okay? Then after you identify the functional dependency, we can proceed the first normal form, second normal form, third normal form, and in the next class. Any question? Okay, thank you.